today's class. For today, we're discussing about motion in physics. So, discussing about motion, I'll be using the idea of equations of motion to solve various jam past questions, right? So let's start with the definition of motion. What is motion by definition? Motion is simply the change of a body or an object with respect to time. So if let's say I'm in this position, I'm coming forward now, I just move 2 seconds, one step and the other step. Let's assume 2 seconds. So motion is simply the change of a body, right, with respect to time. So I didn't just fly, I'm not flash. Actually, it took me some time to be here, right? So if I'm taking backward, I'm going backward here, it's still motion, right? But it's actually it's used with respect to time. So I'm saying that motion is simply the change of a body or an object with respect to time. That's all. Alright. Motion for a layman definition is simply the change of the movement of a body. Is still very much more correct, right? So I will consider the definition of motion and the layman definition, right? Let's discuss the equations of motion. Equation, or perhaps you call it equation of uniformly accelerated motion. So let's call it equation of uniformly accelerated motion, right? So for this one here, the formula goes below. Number one, I have that v is equals to u plus at. Number two, I have that v squared is equals to u squared plus 2ax. For the third formula, I have that x is equal to ut plus 1 over 2 at squared. And 4, I have that actually these are the three major equations of motion, right? These are the three main equations of motion, but there's still one more, but that is not actually very common, right? But there's still one more. So that's x is equal to u plus v all over 2 t. It's like the fourth formula for equation of motion, or perhaps we call it equation of uniformly accelerated motion. That v is equal to u plus at, v squared is equal to u squared plus 2ax, x is equal to ut plus 1 over 2 at squared, and that is equal to this, right? Alright, at this point here, let's define parameter. What's v? What's u? What's a? What's t? Now look at this. Let's set parameter please. From here, where v is called final velocity, u is called initial velocity. This is in meter per second, right? I have a as acceleration, right? A is acceleration, right? What again there? X there is said to be distance or perhaps displacement. Anyone. Acceleration is what? Meter per second squared. Distance is in meters, right? Meters. What again there? T is time in second, right? So when it comes to equation of uniformly accelerated motion, note that this small t is intentional, right? So if I'm using capital T here, it's not more time. It is capital T in physics either represents temperature or period, right? But this T here, small t is actually intentional here. So this T is what is time, right? In second. So we have actually defined all the parameters here. So that v is final velocity, u is initial velocity, a is acceleration of body meter per second square. S is distance, or perhaps displacement in meters, and I have T in time in seconds. So, alright, after discuss all this, let's discuss some concept before we start solving problems, right? Let's talk on other concept here. So, let's discuss something very, very important. Note the following. Please, very important concept, please. Put down. Whenever a body starts or begins from rest, its initial velocity, that is, note number one, its initial velocity, that is u, is equal to 0. So when a body starts or perhaps begin from rest, its initial velocity is equal to 0, that is u is 0. Note number two, is that when a body comes down to rest, right, after undergoing motion, its final velocity is equal to 0, that is v is equal to 0. So these are like the two conditions here you need to master, right? So whenever you see a question, actually v and u are not that always given. So from the question, if you hear the word a body begins or starts from rest, you should know that its initial velocity is 0, u is 0. Or perhaps you hear a question that says that a body is coming down to a rest, so it means that the velocity v is what? Is 0. That's like the conditions there you need to note. Alright, after all this concept here, let's discuss one more thing before we move to free fall, right? Let's discuss what you mean by retardation. What's retardation? Alright, retardation let's discuss retardation. By definition, retardation is simply negative acceleration. It occurs when brake is applied to a moving vehicle, right? So when the word retardation is quite a simple stuff to understand. Let's say for instance, a car is moving, right, with a very high speed, and it sees a boy across the path. So he does not how he will try to press a brake. So in the process of pressing the brake, the car moves what? It comes to rest. That's the idea there is what is retardation. So the car retardates. Also note that retardation is also called deceleration, right? So also called discuss about retardation, that it is simply what a negative acceleration. So mathematically, retardation is equal to what? Negative acceleration, that is minus a in what then? In meter per second square. So retardation is simply negative acceleration. Now let me explain something this. Whenever it comes to equation of uniformly accelerated motion, right? The motion is being undergo on a surface, right? On a horizontal surface, right? So if a car or perhaps a train is moving, a train can never move up or down. It moves what? Horizontal, either left or right is a case to it. So when a body is moving in distance, or perhaps is traveling a distance, right? Whenever you hear the word distance, distance is actually representing a horizontal motion, right? So when it comes to the equation of uniform accelerated motion, note that the body or the motion or the object is traveling horizontally, right? Either left or right. Left or right is a case to it, right? That's like the idea behind this man here. Let's discuss one more concept called free fall. What's free fall? Let's discuss free fall. Alright, let's discuss free fall. What's free fall? What's fall? How do you describe fall in physics? When it comes to free fall, definition put down, free fall is simply a vertical motion under of a body, perhaps. Free fall is simply a vertical motion of a body under the influence of gravity. That's all. Now, when it comes to free fall, listen, the difference between equation of uniformly extended motion and free fall is that whenever a body is moving upward or downward, the idea changes, becomes a free fall. But when a body is moving horizontally, we use what the equation of uniformly accelerated motion. So when it comes to free fall, there's something you need to note, right? So we have just defined free fall. So whenever a body is moving either upward or downward, the vertical sense. So we said the vertical motion, right? Either upward or downward is the case to it. So we use the idea of free fall. So when it comes to free fall, note the following. Note number one, note number one, note that when it comes to free fall, note the following. Number one, the acceleration of a body is equal to acceleration due to gravity. So the acceleration of a body, that is A, is equal to what? Acceleration due to gravity, that's G. So we are saying that when it comes to free fall, the acceleration of a body is equal to acceleration due to gravity. Note number two, note number two is that, sorry, note number two is that the distance of a body is equal to the height traveled by the body. So we're saying that that is the distance x of a body is equal to the height traveled by that body. So when it comes to free fall, note that a is acceleration here, s is distance here. So when it comes to free fall also follow the same pattern of formula. But what changes there is what? You change your A to G and S to H. So for free fall, sorry, right. For free fall, so the equation goes below. Start with this. I have V is equal to U plus AT. V is equal to U plus, we said A is equal to what? Gravity. That's G. Next up, T. I have my T. This is the first equation. The second one goes below. I have V squared is equal to U squared plus 2GH. We said change the S to H, right? H, and change the A to G, right? That's for free fall. Please, plus or minus, plus or minus. Next up, I have X is equal to ut plus or minus half gt squared. I said change a to g for free fall. All right, these are the three major equations of free fall. So the idea changes for free fall. Listen, I will show you how to identify questions. Whenever I see a question, how do you know that question is talking about free fall? How do you know the question talking about equation of uniformly accelerated motion? I will show you. It's quite simple. The tax there is that, let me explain. The tax says that whenever it comes to equation of uniformly accelerated motion, in the question you'll be hearing that a train or perhaps a car, can a car move vertical in a vertical motion? No, a car move what? Horizontal. Or perhaps you hear the word train. So those stuffs move what? The horizontal, in horizontal sense. So it means that I'll be using the equation of uniformly accelerated motion. But when you want the word a plane, yes, a plane, or perhaps you want a car is falling from, or perhaps an apple is falling from a tree. Those one are what? Equation of free fall. So use this guy. Now, when it comes to free fall, when are you meant to use plus? And when are you meant to use minus? Because I'm having plus and minus there. So there's a case to that. So whenever you're using minus, there's a condition guiding it. Whenever you're using plus, there's also the condition guiding it. So note, let me explain when to use plus and minus. Note number one, when it comes to using plus, note that when a body is falling towards gravity, when if a body is falling, right, towards gravity, positive sign is used. So whenever a body is falling this way, right, this body is falling, it's a motion towards gravity, right? So whenever a motion is moving towards gravity, hence positive sign is used, right? So note that number one. Number two is that here we're saying that for case one here, whenever a body is moving downward, is falling, right? A body is moving downward, right? We said we use positive sign. Whenever a body is moving upward, right, against gravity, that is you use negative sign, right? So the reason why I'm using positive sign for case one is that it is motion towards gravity. The reason why I'm using negative sign for case two is that it is motion against gravity. So for case one, the body is falling downward in a what? But is downward or upward is still a case to what? Vertical motion for free fall, right? So either moving up or down is the case to it. But I'm explaining that when the body is moving upward, it is what? Motion against gravity. You're using negative sign. That's for case two. But when the body is falling downwards, right, in this sense, falling, it means that it is motion towards gravity. That's like the idea behind the equation of free fall and equation of uniformly assisted motion. Let me use a diagram to differentiate between the two for better understanding. When it comes to this one here, either the body is moving like this or like this, in this sense for this one. For free fall, either the body is moving upward or downward. That's like the difference between this motion, right, behind this stuff. All right, let's use all this idea to solve jam pass questions and white questions based on the concept of motion. All right, before we start solving past questions, let's summarize what we have just said. So we said for equation of uniformly accelerated motion, I gave you that v is equal to u plus at. V squared is equal to u squared plus um 2s 2ax 3 um 3, that's s is equal to ut plus 1 over 2 at squared. And for 4, that one is not a major. These are the three major ones, but the 4 is still optional. U plus v over 2t, right? So those are the three major ones. But I gave you this. I gave it for free 4. For free 4, I gave you that v is equal to u plus or minus. We said a becomes g, and I have my t. For 6, I have that v squared is equal to u squared plus or minus 2. We said a changes to g, s becomes h. For 7, I have that x, perhaps s becomes h, is equal to ut plus or minus 1 over 2 g t squared. So these are like what we have discussed so far, right? So let's use idea to solve problems, right? Because it says a train with an initial velocity of 20 meter, right, per second is subjected to a uniformly deceleration of 2 meter per second squared, full stop. Calculate the time taken to bring the train to a complete half. Half is spelled H-A, I mean half. Half, half. That is to bring the train to rest, right? Half means to rest. I bring something down to rest. So let's start with solving the question. Our first task in physics, or perhaps in science concept, is to list out the given parameter, right? So what am I given first? I'm given that the initial velocity, that's u. You said solution, that's u. U is given to be what? U is given to be 20 meter per second. Next is subjected to a uniformly deceleration of 2 meter per second. I said you are hearing the word deceleration. We just discussed that deceleration, or perhaps we said retardation, is also called deceleration, and it's what? Negative acceleration. So I'm hearing deceleration. It also means what? Acceleration, but what there is a negative acceleration. So of what? 2 meter per second. So I'm giving it to be what? 2 meter per second squared, perhaps second squared. So I'm told to calculate the time. So I'm looking for time t. Right? I'm looking for time. So now look up. I'm still given something in the question, but it's not actually stated there. But let me read the question again. I said a train with an initial velocity of 20 meter per second is subjected to a motion deceleration, perhaps to a uniform deceleration of 2 meter per second. Calculate or perhaps the time taken to bring the car to rest, or perhaps to bring the train to rest. I said that when it comes to equation of uniform accelerated motion, I'm in a train. So a train will move horizontally. So I'm using this condition here, just this one, 1 to 4, right? But observe that I'm told that to calculate the time for to bring the body to rest. I gave you note number 2 under this concept that whenever a body is coming to rest, its final velocity is equal to 0. So it means that v here is equal to 0. So your task is that I said u and v will not be given, but from the question you phrase out your v and u. So in this case my v is 0. So I'm looking for t. With this 4 equation here, which one suits I'm looking for c? Which one is actually which one goes with looking for c? I have u, a, t, v. I'm looking for t. I can actually use equation 1, that is v is equals to u plus at. So recall that we said that v is equal to u plus at. So I can easily look for my t here because all these parameters are given. What's v? V is 0 is equal to, what's u? We said u is 20 plus a. What's my a? Minus 2 multiplied by, what's t? I don't know. T is unknown. From here, I have that is 0 is equal to 20 plus 2 minus 2 times c is minus 2t. I have this. From here, is 0 is equal to 20 plus times minus is minus 2t. Take minus 2t here becomes plus 2t being equal to this 20. Divide here by 2. Divide here by 2. I have that t. Therefore, t is equal to 20 all over 2. Finally, t is what? 10 in second. So the time taken to bring the train to rest is simply what there? 10 seconds, right? So that it works. Let's take one more example and solve together. All right, example 2 says, calculate the total distance covered by a train before coming to rest if its initial speed is 30 meter per second with a constant retardation of 0.1 meter per second squared. So first task, list out the given parameter. So solution. So my first task there is that I'm given what? I'm told to calculate total distance, right? That is s. So I'm looking for s, right? Distance before coming to rest. That is actually before something can come to rest, it simply means that at the finally at the final stage it still comes to rest. So when I say that whenever a body is coming to rest after undergoing motion, its final velocity is what? 0. So from that statement there, I can graph out that v is what? Is 0. So we also said if its initial speed and velocity are what? Dimensionally the same. So in this case here, my speed is velocity because they are both in meter per second. So I'm given that speed, or perhaps initial speed, please. If it was speed, that's velocity. But initial speed, that's what? Initial velocity, which is what? U is initial speed, 30 meter per second, with a constant retardation. We said retardation is simply what? Negative acceleration, right? So I'm having a to be what? Minus 0.1 meter per second squared as my negative acceleration. So the option is given below. A is given to be 5 550 um okay 5,500 meter. B is given to be 4,500 meter. C, just use meter. C. D, 3,000 meter, perhaps 4,200 meters. So let's find distance, please. Either of the option one is the answer there. So your first task is to your first task when it comes to motion. Can you recall this formula? That's the first task. Next task is that can you graft out u and v? That's the condition. Let's solve this one here. I'm looking for x. I'm given vu and a. Which one of this equation here can actually find distance? Of course, this equation 2, because check, I'm given v there, I'm given u, and I'm given a. So I'm looking for what? S. So it's possible. I can't use this one because if I'm looking for x, I'm giving u, I'm not given t, time. So I can't use this one. And I can't use this one too because I'm not given time. So the best one to use there is this. So from here, recall that we said v squared is equal to u squared plus 2as, right? So from here, what's v? V is 0. I have is 0 squared is equal to what's u? That's 30 all squared plus 2 into what's a? A is minus 0.1. Next up, multiplying, or perhaps let's say multiplying s. What's x is unknown, right? So from here, is 0 squared is 0 equal to 30 squared is 900 plus look up 2 times minus 0.1, it's simply minus 0.2. So I have minus 0.2 s, right? So 2 times minus 0.1 is minus 0.2, attach this x to it, right? So from here, if I expand this, I'll have that is 0 is equal to 900 plus minus is minus. So I have plus minus is minus, then this man here. So take this one here. I'll have that if minus 0.2x comes, it becomes 0.2x being equal to 900. Divide here by 0.2, divide here by 0.2. It means that this one cancels this, left with x. So it means that x is equal to 900 divided by 0.2, which gives 4,500 in meters as my answer. So my answer there is question, the answer is B. So this is how to solve problem under the equations of motion. Let's take yet other examples, and let's take example under free fall so you know how free fall questions comes.